Hi everyone, welcome back to my channel. This is Mr. Budihas, your online math teacher. In today's video, you will learn how to solve quadratic equations by completing the square. Let's learn first what is completing the square. It is a method for solving quadratic equations by changing an incomplete quadratic trinomial into a perfect square trinomial. Given the standard form of a quadratic equation, ax squared plus bx plus c is equal to 0, this constant c is isolated to the other side of the equation, or we are going to transpose this positive c to the other side, and then the coefficient a will be reduced to 1. Whatever the number here will be reduced to 1. And the completed square is given by the expression, this one. For example, find the number that will complete the square for x squared minus 5x is equal to 0. Here, the constant is already isolated to the other side or to the right-hand side of the equation, and that is equal to 0. And the coefficient of x squared is already 1. Now, to get the number that will complete the square, we are just going to get the half of the middle term or half of the coefficient of the middle term, then we are going to square it. So since the middle term is negative 5, then take the half of it and then square. Negative 5 square, or the square of negative 5 is 25, and the square of 2 is 4. Therefore, the number that will complete the square is 25 over 4. This is on how to find the number that will complete the square. Just take the half of the coefficient of the middle term, then square it. Example number 2. Find the solution or solutions to the quadratic equation x squared plus 4x minus 6 is equal to 0 by completing the square. To find the solution or solutions to the given quadratic equation by completing the square, we need to follow these steps. First, since the coefficient of x squared is already 1, we can proceed right away to isolating the constant to the other side of the equation. And that is, from the original equation, we have now this x squared plus 4x is equal to 6. We isolated the constant term. Second, find the number that will complete the square. Take note, in finding the number that will complete the square, we are just going to take the half of the coefficient of the middle term, then square it. So half of 4 is 2, then take the square of 2, we have 4. And we are going to add this number to both sides of the equation. Then simplify the constant on the right hand side. So we have here 4, and to the other side 6 plus 4 over 2 squared. 4 over 2, that is just 2, then square of 2 is 4. Then 6 plus 4 is equal to 10, then just copy this one. And third, express the left-hand side as a square of a binomial. Since this is already the perfect square trinomial, from an incomplete quadratic equation, we transform it into a perfect square trinomial by completing the square. So we are expecting that the factors must be of this form, since it is already a perfect square trinomial. So the factor of x squared plus 4x plus 4 is equal to the square of x plus 2. Fourth, Extract the square roots of both sides of the equation to find the solution or solutions. Now, square root of the square of x plus 2 is equal to positive negative square root of 10. So this is cancel the exponent and the radical. We have the remaining is x plus 2 is equal to positive negative square root of 10. Since 10 is not a perfect number or perfect square, we'll just let this radical sign be there. And separating the variable term and the constant term, we have this positive 2 is a constant term. We must transpose it to the other side, and it becomes x is equal to negative 2 plus minus square root of 10. Hence, the solution of the quadratic equation x squared plus 4x minus 6 is equal to 0 are negative 2 plus square root of 10 and negative 2 minus square root of 10. And now it's your turn. I want you to solve these problems under individual practice for you to check if you understand the discussion. And I want you to please comment your answers so that I can check also if your answers are correct. And that's all for this video. Thank you for watching.